Here we go, Earth's orbital motion. I want you to take a look at this first blank and see if you can figure out what goes in the blank. Earth moves about blank degrees each day. As it goes around the sun, as the Earth goes around the sun, it moves about blank degrees of its orbit. Think about that for a moment. That would be the answer if it was in a year, it'd be 360 degrees. But just each day, about 1 degree. Right? How'd you guys come up with that? Somebody explain. Go ahead. Perfect. There are 365 days in a year. There are 360 degrees in a circle. So it's about 1 degree per day. Now in this class you're going to be learning a whole lot of our everyday lives. Goes back to astronomy in some way or another. And some things that you probably never thought about in your entire life, you're going to think about differently. You're going to understand the roots. For example, why in the world would there be 360 degrees in a circle? I mean, think about that. Isn't that weird? Have you ever thought about that? Who decided there should be 360? Why aren't there 100 degrees in a circle? Right? Because it all goes back to astronomy. That's why. This isn't a coincidence. It's why there are 360 degrees in a circle. Because ancient people figured out that it was 365 days in a year. That's why. That's why we get 360 degrees in a circle. Now if you're thinking, wait a second, that's all fine and good, but why aren't there 365 degrees in a circle then? Well, here was the problem that ancient people had. As they're trying to work out their calendar, they always had a tough time with calendars, and here's why. For good reason, they wanted 12 months in a year. They had to have 12. Why is 360 better than 365? Yes, it's divisible by 12. See, with 360 days in a year, everything works out beautifully. You have 12 months, 30 days each. Isn't that nice? Isn't that nice? Unlike now where different months have different lengths. You know, now you could have exactly 12 months with exactly 30 days each. So, they would often try to do that. They'd have a calendar that was based on 360. Now, what about the last 5 days? They would get drunk. Boom, that just takes care of it right there. We're just going to party. It's going to be Mardi Gras the last 5 days of the year. I'm serious. That's how they would handle that situation. All right? They would think that the gods had set aside that time just for celebrating or something. Okay? Now, by the way, that led eventually to other things. Because if you base everything on 360, then you have 360 degrees in a circle. You know what 360 also divides by? 60. What does that lead to? Sure. You ever thought about that? Why are there 60 minutes in an hour and 60 seconds in a minute? Because everything was based on 360, and that was easily divisible. You got it? So much of all this stuff that we think of every day that we don't think of all goes back to this fact that we spin around. The Earth spins on its axis 365 times as it makes one orbit around the sun. And they started basing everything on that. Okay. iBook folks. How many are doing iBooks this hour? I would suggest every day, my suggestion is I would have your computers out and I would be working on the iBooks maybe during the lecture, maybe starting tomorrow I would do that. Here is a great vocabulary term for all of you, but especially for the iBooks, it's going to go in your glossary. Circumpolar. What does circum mean? Or circa? Okay. What's another like circa? If you said circa 1942. Around that time, like near, right? Near. So circumpolar means near the pole. Constellations that can be seen all year long. I'm going to try to explain that right now with a little demo. So let me explain first seasonal constellations. So here is the sun and the earth, and let's say that it's springtime in the earth. Now springtime means that the sun's rays are hitting at the equator of the earth. Now we turn around at night, we're facing away from the sun, and we see the springtime constellations. Okay? Leo, Virgo, for example. Now, when we're seeing Leo and Virgo constellations, what about these constellations over here? Are we seeing them? Why not? Because the sun is right there. The sun is in the way. Now those constellations are out, but they're out in the daytime. So in the spring, you're going to see Leo and Virgo over there. You are not going to see Pegasus and Perseus and those over there. Does that make sense? Now let's go a little later in the year. So the Earth now is going around. If you're looking down on the North Pole, we go in a counterclockwise direction. Okay. Now we look out at night. We spin around at night, and we look out, and we're seeing some of these. Now right there we have the summer triangle, for example. Maybe write some of these down, different constellations. So for the spring, we had Leo and Virgo. Spring, Leo, and Virgo. And now it's summertime, and we're seeing, for example, the summer triangle. That's an easy one to remember. Summer triangle. Scorpius, one of my favorites. Okay? Those are the constellations. Sagittarius is another good one. Now, if we're seeing those in the summertime, the ones up here by my computer now, we are not seeing. Like my favorite, Orion and stuff like that. Because when are those out? They're in the winter, but in the summertime they're technically out, but when are they actually out? In the daytime. So right now, my favorite constellation's out. Orion's out today, but I can't see it because it's in the daytime. Does that make sense? All I need to do is just produce a total solar eclipse, and I could show you that. Tech team, let's work on that. I want an app for that. You guys work on that. So let's continue the year. We come around here to the fall now. Now I'm seeing Pegasus. That's one you could write down. The Great Square of Pegasus. Great Square of Pegasus. Okay. Perseus. Another good one. You tell me some constellations you're not going to see. If we have astronomy night in October, then what are you not seeing? Tell me some constellations we will not see in October. Leo and Virgo. Does this make sense? Now finally, we spin around here, the year progresses, finally we get to the winter time. My favorite time to do astronomy. One, because it's nice and cool down here finally. And then two, the sky is beautiful in the winter. And we have Orion, my very favorite constellation, Orion. And we have Taurus, and we have Gemini, and all these great ones. Now tell me some things we're not going to see in the winter. The summer triangle. Yeah, that's a good guess, right? The summer triangle and Scorpius and Sagittarius. All right. So, getting back to the vocab there. Circumpolar. Here's the thing. I've been having this go around in a circle. But there are other constellations up here above the pole, like on the ceiling. Look what happens. As I spin this around all year long, the constellations that are on the ceiling, we can see those all year round. Does that make sense? I'm going to show you a different map here very quickly. So this is kind of a neat star chart. It's very different than most star charts because instead of showing the sky like from your particular latitude or whatever, it's showing a map based on the North Star. Polaris is right at the center. Now what I want to focus on is the little circle there. You see the inner circle? Yeah. Can any of you sitting in this area, can you read off some of the constellations? Do you see anything you notice there that you know inside that circle? Draco?
There's one upside down.
Do you see? Very good. The Little Dipper right in the center and the Big Dipper right on the edge. Now what that means is the ones that are inside the circle are circumpolar. We can see those all year round. They're far enough north that we can see them all year. Now the ones that are on the edge, like Cassiopeia, okay, the W shape, and the Big Dipper, those you can technically see all year round, but they're better at certain times of the year. The Big Dipper tends to be higher in the spring and the summer, and Cassiopeia tends to be higher in the fall and the winter, but they're all circumpolar. We can see them all year round. So, finally, we said that the ones that are above the North Pole are circumpolar, and we can see them all year round. But there are some more constellations that I haven't mentioned. Where are they? South Pole. Ah, yes. We also have constellations down here below the South Pole. Now, they're circumpolar if you live in the southern hemisphere. When do we see those constellations? Never. So it's the exact opposite. The ones that are the northern circumpolar we see all year, and the southern circumpolar we don't get to see at all. If you want to see those, you need to go south. And I'm going to show you those right now on the screen. So let's take a look at some of the southern constellations, some of the circumpolar constellations in the south. Let's take a close look. First of all, on the screen, right here, that little plus mark there, that is the south celestial pole. That is due south. You notice there's no bright star in that area. That's why there's no south star. So let's look at the constellations that we never get to see at astronomy night. All your favorites. Look, Octans and Pavo and Musca. Yeah, a whole lot that you've never heard of, right? Now, by the way, on this map, I noticed that, like, if we go out tomorrow night for astronomy night, here's as far south as I can show you this time of year. We are going to see Sagittarius, and we're going to see Scorpius, and they're going to be at our very southern horizon. Okay? And that's it. That's kind of the cutoff line for South Florida. That's where we can see. We can't see any of these. Okay? Now, in the southern hemisphere, there are two constellations I want you to know. Write them down. By far, the most famous one is right here. There, look at this. 4 bright stars very close together. 1, 2, 3, 4. Its official name is Crux. C-R-U-X. It's the smallest constellation, even though it has 4 bright stars. But what is its famous nickname? The Southern Cross. Good job, Quiggs. The Southern Cross. That's what sailors would look for. They would know they were very far south when they started seeing the Southern Cross. Very famous. It's really beautiful in the sky. Now, here's something I learned in Peru a couple of years ago with the students. We're walking around Peru, and I start pointing out what I thought was the Southern Cross. And somebody corrected me and said, oh no, there's a fake cross as well. So how do you know it's the real Southern Cross? I'm going to show you 2 ways in case you're traveling and you want to know the difference. First of all, the other constellation that I want you to know in the south is called Centaurus. C-E-N-T-A-U-R-U-S. Centaurus. What's its brightest star called? Alpha Centauri. What's special about Alpha Centauri? Very good. It's our next door neighbor star, Alpha Centauri. And guess what's right next to it? That's Beta Centauri. So if you're in the southern hemisphere, what I started looking for in Peru, I started looking not only for the cross, but I'd look close to it and see if there were 2 bright stars side by side, Alpha and Beta Centauri, and then I knew it was the real Southern Cross. I'm going to show you the other way in just a second. But Centaurus it kind of wraps around the Southern Cross. So if you find one of them, you're going to find both of them together. Okay, the Southern Cross and Centaurus, very interesting patch of sky, lots of cool stuff going on. Here's a picture that I took in Peru. What's going down the middle there? The Milky Way, very beautiful there. And let me show you a picture that Mr. Simpson took the same night. He's a professional photographer, so anytime I'd steal one of his pictures, you'll see his logo there. But anyway, this one's turned a little differently. There's Alpha Centauri, Beta Centauri. Now do you see the cross? There it is. Here's the other way you know it's the real Southern Cross. There's a 5th star that's pretty bright right there. That's one you're going to see pretty easily. So it's really 5 stars. You have the cross and this one here. The fake cross doesn't have that 5th star. Okay? You see it's right there in a nice patch of the Milky Way. Just a beautiful, interesting part of the sky. A lot of stuff happening there around the Southern Cross and Centaurus. Some more of Mr. Simpson's pictures from that night. Okay, take a look at this, just for fun. I told you you'd look at some things differently from now on. Some flags from countries in the Southern Hemisphere. What do they all have in common? Yeah, look at that, the Southern Cross. What country? Australia. Australia, and there you go. Now for some reason, look at this, Australia put in the 5th star there for their Southern Cross. New Zealand didn't. I don't know why, but they decided it wasn't important enough to get a spot on their flag, I guess. Okay, I don't remember what countries these are here. A couple more southern hemisphere countries, maybe island countries. And then check this one out, one that we all know well. We got a lot of exposure this summer, of course, from the World Cup. Brazil, that's right. Now, take a closer look at Brazil's flag. I bet you've never really thought about or noticed all the stars on there. Now, unlike the American flag where the stars obviously are just kind of in columns or whatever, these are actually constellations. They're the actual constellations in the southern hemisphere. And as a matter of fact, which one's right there? The Southern Cross. One more little fun fact. It's not completely random either. They have southern constellations, and it turns out that the number of stars is the number of districts in Brazil as well. So that's also part of that.
What's the big star on your shirt?
I don't know, actually. I asked somebody last hour that's from Australia, and he didn't know. So it could be. Do you think so, Alpha Centauri? Oh, is that for sure? You know that? Just guessing, right? That would be my guess too, but I don't know for sure. We'll have to look that up. Yes. No, you didn't see that. I'm absolutely sure of that.
It looks familiar.
Yeah, it wasn't that. What you probably saw, which what's called the Pleiades cluster. It looks like a little dipper in the sky. Well, even that, I'm not sure you could see it from there. I don't know what you saw, but I do know that it wasn't the Little Dipper in Brazil. That's guaranteed. No, I guarantee you did not. But I'd be curious. I'm not sure what you saw, but a lot of things you can, people mistake things for the dippers all the time. All right, some more pictures from the Southern Hemisphere. Just beautiful, beautiful pictures there. All right. Important concept here, the ecliptic. iBook, folks, this is a great one for your glossary. By the way, where's our art department in here? Who's the art team? Something to think about, like this demo that I just did, that's what some of the groups are making. That's kind of on your list of things to make something that's better than this, and these like piece of paper, to have like a model built that I could put in the middle of the room and actually show that, illustrate that. That's kind of a challenge for you guys to make. And the film crews are going to use that to make the little videos. But anyway, the ecliptic. Let me give you the simplest explanation that I can of the ecliptic. Keeping in mind, guys, that ancient people all believed, all different cultures around the world believed that the sun went around the earth. Okay, in very ancient times anyway. They all believed the sun was going around the earth, right? So let's think about this. To them, the sun's coming up in the east, going across the sky, and setting in the west. Here's what I want you to pretend. Pretend that today, when the sun does that, it leaves a trail behind, like a glowing trail, okay, a fluorescent trail through the sky. And then tonight, excuse me, tonight, when it gets dark, the trail is still there in the sky. Like there's a glowing path, a line through the sky. That line is the ecliptic. You got it? That's the simplest explanation I can give you. It's the sun's imaginary path through the sky, that line in the sky. Now, what are you going to find along the ecliptic? Well, lots of important things. For example, the moon will be usually close to the ecliptic, and as a matter of fact, the moon has to be right on the ecliptic for what to occur? An eclipse. Hence the name ecliptic. You got it? The planets are all going to be close to the ecliptic. And the reason is that our solar system is on a pretty flat plane. And so the planets are always hanging out along the ecliptic. You're not going to see planets going through the Little Dipper. They're always going to be going along that glowing line in the sky. Does that make sense? Okay? Very important. That's one of the most important parts of the sky there. And I'll point out, hopefully we'll have a night this year when we have like 3 or 4 planets out at a time. That's always fun, and I'll show you that they're actually lined up along the ecliptic. Now, let's tie this in with something here. Let's tie this all together. Ancient people, again, thinking that the sun is traveling around us They figured out, hey, we're seeing the same constellations over and over again. They figured out the ones that the sun was traveling through. How many did they think the sun was traveling through? 12. What do we call those 12? The zodiac. The zodiac. That's why those 12 are special. Now, in case anybody calls me out on this, just in case, especially those of you watching the video and research team, in the video they mentioned the fact that with the modern set of constellations, the sun actually goes through just a little bit for a couple days through a 13th constellation. It's called Ophiuchus. Not one of my favorites. But Ophiuchus, just technically, if you read that somewhere, that's true. The sun does pass through a 13th in the modern set of constellations. What else do those constellations have in common? Nothing. They have nothing else in common. Look at the zodiac. Some of them have bright stars, like Scorpius, like Gemini, like Taurus. Some of them have no bright stars at all. Okay, Cancer the crab, and Libra, and Pisces, and Aquarius. Some of them are very ancient, like Pisces, goes back thousands of years, and some of them are relatively new, like Libra. They only came up with that one about 100 years ago, the scales. So they have nothing else in common. They are the ones that ancient people realized or thought the sun was passing through. Now let's see how this works out with your so-called sign, okay? Here's how this works, and it may surprise you how this works. Let's say, for example, that you were born in November, and that your sign is Scorpio. Now, what did that mean? How did they come up with that sign? Because in November, they realized that the sun, or they thought the sun was traveling through Scorpius in November. So let's say on your birthday, you decide, hey, I want to go out and see my constellation on my birthday. So here you are in November, the sun's passing through Scorpius. You go out at night. You're going to be very disappointed. You're seeing Taurus and Gemini and Aries, and you're like, wait a second, where did mine go? Because on your birthday, your constellation is out, but it's out when? During the day. Your constellation, your sign is out on your birthday during the day, so you don't get to see it. The best time to see it's on your half birthday. Okay? So on your half birthday, now let's say it's May. Now you go out at night, when it's nowhere close to your birthday, and now you get to see, Scorpius starting to come out. Got it? Whereas the sign for May is, a lot of May birthdays then would be Taurus. It's kind of different probably than you expected, right? It's kind of weird. Yes?
So is that whole astrology and everything, it shows opposites, so basically
Opposites how? I don't know what you mean. Like
opposite compatibility, like Aries,
I don't know that aspect. I don't know what they believe in that, but yeah, I don't know if that's tied in with this physically or not. Because I don't know how that works. Speaking of astrology, this is the only time I'm going to mention astrology. Now listen, you can believe in whatever you want to believe in, okay? If you want to believe in astrology, that's absolutely fine, but please don't tell people you're taking astrology. Okay? That's not what this is. This is astronomy. This is the science of the stars and planets. Okay? This is a belief system. Those are different things. Okay? We'll never talk about astrology in here. We're talking about the actual constellations and what they contain in that patch of sky. So that's very, very different thing. Okay? But I want to tell you one quick thing about astrology just so you understand sort of how this got started. One thing you should maybe know about it is this, that when astrology started, it had nothing to do with like individuals and their horoscopes. That came later. See, what would happen is this, maybe in very ancient times, you would have some really smart person in the kingdom that could figure out the skies. Specifically, maybe they could predict an eclipse. Now that's powerful stuff, right? If you tell people, hey, guess what's going to happen this afternoon? Yeah, the moon's going to block out the sun, just wait. And then it happens, man, everybody's freaking out. Like, you're a very powerful person, right? And the king's going to grab you by the shoulder and say, hey, come here, come here. You're going to be my assistant here. You're going to be my advisor. And so that's how really it got started. Because then his advisor, he would say, listen, I'm thinking about, attacking this other country. What do you think? How's it look in the sky right now? And if you're the chief astrologer or whatever, maybe you're like, well, you know what? I like where Mars is at right now. I like it. Let's go kill some people. Okay? And that's how it started, just with the king or the whole country. Later on, the Greeks took this idea. You know how the Greeks were? The Greeks liked getting everybody involved, right? Everyday people. Like when they came up with that whole thing, what was it called? Democracy. Yes, democracy, right? Getting people involved, right? They did the same thing with astrology. They're the ones responsible for you having a personal horoscope. They brought it to the masses, in other words. Any questions on that or on the seasonal constellations, circumpolar constellations, anything along those lines? Thanks for listening, guys.